Okay.
Sweet. So I have started researching Java collections. Um, I don't remember, Greg, when you studied, did you study the map stuff too, as well?
Um, yeah, I went and lists, map, trees. Learning more about trees and maps, and then sets I know as well.
Okay. So, um, from what I understand so far, basically there's three types of collections: array lists, tree sets, and linked lists. And then there are the two most common types of maps are hash maps and tree maps. So I've been looking at the code that Brother Barney has in his book, and it looks pretty straightforward from what I can see. I was just starting to work on some sandbox code before the video call, so I won't have anything finished for tonight, but for Thursday I definitely will. So um, just something I looked at here. Basically, an array list is a type of collection that it's like an array and it's sorted. A tree set uh, is with objects, and the objects are pre-sorted, and a linked list is an unsorted collection, and you can add any number of objects multiple or any object multiple times. So yeah, that's about it for me tonight.
Coolio. Corey.
Okay, so I've been working on the JSON stuff. Um, oh, I just lost my spot in the book. So JSON is, for my it's a way to serialize, turn that crunchy goodness that you eat with milk. Okay, not really, but it's a way to serialize data. And so what that means is it's a lot easier, or eat up less bandwidth to send data across the network, across something as a hash than to send the entire object. And so what JSON does is it basically takes your object or wherever you've created and squishes it down into like a hash, basically, from my understanding. And that's what gets sent across as part of the communication between the app and everything else, your database or whatever it is that you're using JSON to communicate with. I haven't hopped into the QC JSON just yet, but for the JSON, so it helps with that. So that way, you're being more effective, especially if you're stuck on bandwidth or you're trying to move stuff quickly. Sometimes moving the objects can take a lot longer. And JSON, like I said, because it does it as a hash, it does it as a text-based versus like an object-based. The two things that are done most obviously with that, though, are arrays and objects. And hopefully I can get some sandbox code on Thursday. So working on that hopefully, and then Thursday maybe I'll be able to find something about some QC JSON. But that's what I've got to report so far on the QC or on the JSON. While I've learned about it. Once you see some code and some stuff, I should be able to help understand it a bit better. But
Perfect.
that's it for
Thank
me.
you. Thank you, Corey. Jacob, how are you doing?
So the book that I've been sent to read, I've now finished multiple times. Brother Barney had told me to view through all the code, like all the files of the code, which I had done, and now he wants me to play around with it. So um, it's making more sense. So at least as far as reading it. So I'll be playing around with it for the next day or two, and I'll get back on you with that. Just the basic things like the loops, the arrays. I am making steady progress.
Awesome. Cool. Good, good. Well, feel free to ask any of us three here for help if you ever need anything, an explanation or anything like that. Not that we're Java pros, but I mean, maybe we can put in English that Brother Barney can't. So.
Well, I do have a question. It in the code, there's this whole deal with the throws exception words.
Okay.
You go through the whole public static void main string args, and then oftentimes after that is the throws exception.
Right.
So I'm not fully understanding when you would and would not need to have that.
On the function name or inside the function itself?
It's within the class. It would be like the examples I've seen was on the same line as public static void main,
Okay.
throws exception, and then the opening curly brace.
Okay.
Well, even inside or outside the function, I'm not so sure on what the purpose of it is.
Okay. Well, first of all, Jerem and Corey, do you guys want to comment on this at all? Jerem?
I don't have any particular comments that came to mind.
Have you ever used it in a sandbox code or anything?
No, I'm still trying to figure out how to work with sandbox code exactly because the JSON wasn't working quite well for me and trying to get it to work with Java, so I'm not quite sure what to say.
Going back on that, does he want you to work with both QJSON and JSON, or just one or the other?
I think he wants both. I think well, the QC JSON is a library that he's built for Java to make it easier to interface with JSON.
So would that be two different sandbox code or just one?
It's
One. My understanding. Like Darren was saying, it's a library, so it's like a package you download, and then you use JSON with the QJSON package, or bundle or whatever.
So I have some code right here for you, Jacob. Let's see, for instance, it's not like syntactically, whatever, 100% correct, but it should give you an idea. So for instance, sorry, let me just equals. Hi. And okay, so Jacob, do you understand what a try catch is? You're muted. I can't hear you.
Somewhat.
Okay. So let me share my screen with you, and I'll explain it to the best of my knowledge. Where's my code? There we go. All right. Do you see this here, Jacob?
Yes.
Is it small or can you see it okay?
I see it okay.
All right, let me just see if I can zoom on this thing at all? Come on, where's the zoom?
I can see it okay.
Okay. All right, so long story short, let's say you have a function. Okay, in this example, we're going to use main. Okay, right here. Now, in your logic or your function, no matter where it is, you can say try, and then what it does is it tries to execute the following code. If that doesn't work, there'll be a throw somewhere, and then you catch it and you display an error. For instance, var I equals function name. Okay, it's going to call this function name, which is here, and then if something happens in here, throw an exception, meaning say, hey, catch me, I'm throwing an error. So if something is false, let's say, if something's true, let's execute this line of code. Else, if it's not true, throw an exception. And then what this does is this just passes it along. So it'll go from here to here, and then it'll return the exception, and it's going to catch it saying, okay, I got an exception back instead of what I was supposed to get back. And so it's just a way of error handling. Instead of having your entire program crash, you can catch certain things and handle it. Does that make sense?
A little bit.
All right, let me give you a different example then, because I actually have some code in IntelliJ I can use. Let me just boot up IntelliJ here. While that's booting up, I'm happy to say that I watched a 45-minute Indian person try to explain Hibernate to me. That was interesting.
So how much did you understand, or did you take away from it?
I took away a little bit, enough, I think so.
You took away a little.
Okay, let me open up my code here.
No, Ender.
All right, let me screen share this again, and then once I give a couple examples of my code, hopefully that'll help you, Jacob. All right, you see that okay, Jacob?
Yes, I see it.
Okay, so we're gonna do this one here. Okay. So in this function, remove, which I call, we'll just do this top one actually. So string array list. I call that in my main function, and it's right here, my first function call. So I go in there, I say try, execute this block of code. Okay. And if there are any errors here, for instance, let's say I can't add the New York Jets for some reason, it'll throw an error and it'll say error printing team. So it's like an if-else. If this code works, execute it. Great. If this code doesn't work, else print an error. Does that make more sense, Jacob?
Yes.
So I actually wrote some C++ code that did if-else instead of try-catch. It's the same kind of principle. Try-catches are just made for error checking, or to catch problems. So for instance, this one here is a nasty path, and I'm creating a game, a neg team, it's just what I call it, because I try to add a negative value as an index, which you can't do. And because I can't do that, instead of crashing my program and saying, okay, you can't do this, it catches the exception, can't add something to negative index value is what it prints out. And it keeps running the program instead of crashing it. So, for instance, let me go ahead and run my program real quick. Hold on, I gotta make it first. Okay, so I'm gonna run my code, and it's gonna print out. Let me go ahead and show you what's going on. Okay. Alright, so we're just going to focus on the add negative index. So all this stuff, ignore this. Okay, so I try to add this negative index, and I can't because it's illegal. You can't do that. The code's going to, normally it should crash your program. Okay. However, instead of crashing the program, it'll say can't add something to a negative index value, which is right here. Does it make sense?
Can you try running it? Can you take out your nasty path, the exception handling part, and just run it with the?
Yeah.
See what happens.
Yeah. Let me just delete this here. Oh, don't want to do that. That's what's going to crash it. All right. So trying to run this without my try catch. Let me recompile this. Where's the compile word? Where'd it go? Alright, hold on, let me rebuild it. Sorry. Take a second. Okay, now, watch because it's going to crash it. I'm going to run it, and bam. Instead of catching that error and printing out a statement saying, hey, you got a problem, it just crashes and it doesn't keep running. It'll print all of this, but once it gets to that function, it won't print the, hey, can't add negative index value. Now it just crashes.
Well, it seems like you have a value outside of the index.
Exactly.
Right.
So what I was doing here is this is a nasty path, meaning you try to break the code. Okay. Now, if you write nasty paths and you don't catch, then you can't ever finish your program because it'll just stop it like it did here. Because I have functions after this that I need to print, but they won't print because this crashes my program here. So in order to continue with my program, what I do then is I have a try this code. If there are any problems, let me know by telling me here. Does that make more sense, Jacob?
Yeah, it does.
So this is super, super good for the nasty path. And even the non-nasty ones, happy paths. You should always try catch when you don't know if it's going to work or not. In theory, you should always try catch, but in sandbox code, I imagine it's more important because you have to actually run to show what does and does not work. We good? You understand a bit more?
Yeah,
Okay.
yeah, I do.
Perfect. So I hope that helped a bit. I don't want to keep everyone much longer, so I'm actually going to go ahead and start with my little shindig thing. So with Hibernate, it's pretty much like a middleman between MySQL and Java. The good part about Hibernate is you don't need to know any MySQL commands whatsoever. According to what Mr. Indian said, all you got to do is know certain Hibernate commands, interact with the database, and it does everything for you. Objects, pulling data, pushing data, anything, Hibernate will do for you. You just have to know a couple commands. So it handles all database interaction. I didn't necessarily get a chance to investigate more than that as to actually importing it to my IDE or writing functions to interact with the database, all that kind of stuff. I'm hoping to have some of that by Thursday. But just knowing that, it's actually pretty sweet because you can interact with any database. So whether it be a MySQL or an Oracle database or different syntax, Hibernate will handle it, which is nice for like a company. For instance, if they have a program and they're linked up to a database, if they implement Hibernate, they can use a MySQL, a JSON, they can use any kind of database they want because Hibernate will handle the transition of the data. So it seems pretty nifty. That's all I've got at the moment. My computer was like broken yesterday, so it was gone all day. My Linux partition overrode my Mac bootloader, and so I was stuck in elementary OS, and so I had to erase that bootloader so it would by default boot into Mac. Long story short, my computer was broken all day yesterday. So today's my first day with my computer back, and I'm happy.
Nice.
So yeah, that's about it.
Okay.
Let's plan on, I guess if you guys want to come to class tomorrow, great. If not, that's fine. I'm meeting with Brother Barney tomorrow to kind of talk about the group work and just, I haven't had a meeting with him yet. And then Thursday we're planning on meeting, like physically meeting in a group setting. Is that correct?
Yep, I'm working on right now and booking a. I'm working on reserving a room again for Thursday.
Sweet. So Corey, if you wouldn't mind sending that text out to everyone.
I'll tell you.
And then we can also do the Hangouts Thursday night, and that should be good. We should be relatively close to switching subjects at a point, right?
Yeah.
Cool. So it'll be, we'll rotate one more time, and then so next Thursday we'll pick a new trio of subjects.
Okay.
Cool.
Along with the rotational subjects, someone had mentioned in the other groups, it might be beneficial if we go in the order that the topics appear in the book. If we're jumping, because I know Hibernate when I was doing it's kind of there at the back end of the book. So if we kind of try to follow the logical, or hopefully it's a logical progression in the book, chapter 1, chapter 2, that way we're not hopping back and forth. It might be a little bit easier for us to build on these different topics.
Okay, sounds good.
So, food for thought when we get to there.
Cool.
Once I'm booking this go, and then I can tell you guys where we're going to be at. What? Oh. Of course, there's nothing open today because it's past. There we go.
All right. Well, I'm going to stop the broadcast.